All right, now we're going to look at perimeter, and we're going to find perimeter and area in the coordinate or on the coordinate plane. So triangles, rectangles, parallelograms, any quadrilateral, basically, trapezoid. It might be a pentagon, an octagon, a hexagon. We could find a perimeter and area of anything as long as if we have it graphed. Okay, and we're going to show you how to do this. First of all, perimeter is pretty simple because perimeter is just adding up the lengths of all the sides. So basically, to find the perimeter of this one here, this triangle, I have side AB, I have BC, and I have AC. And I'm just going to add up all three sides, the lengths. Well, the problem is I can't count the length because it's not up and down or left and right. If it was, if it was like this, if it was a triangle where it went like this, okay, or say a square, for example, or a rectangle. Okay, if I had that, I could go 3, 4, 3, 4, and I can count them. You can't count the diagonal. So what we have to do is we have to use the distance formula to find the distance between 2 points. That's going to be the length of the segment. So I'm going to do AB equals, okay, distance formula. So that's going to be x2 minus x1 squared, and then y2 minus y1 squared. We should know this by now. All right, so AB is going to be negative 3 minus 1 squared, and then 4 minus 7 squared. That's going to be 2. Nope, it's going to be negative 4. And negative 4 squared is 16. And then negative 3 squared is 9. So this is going to be the square root of 25, which is 5. BC BC, 7 minus 1, or let's do 1 minus 7. And then this 7 minus a negative 1. Double negative becomes positive. This is going to be negative 6 squared is 36. And what does that even say? 7 plus 1. Because it's minus a negative 1. That's 8 squared is 64. So that's going to be 100. And the square root of 100 is 10. Now AC, A to C, negative 3 minus 7, 4 minus negative 1. So that's going to be negative 10 squared, which is 100. And then 5 squared, which is 25. So that's going to be the square root of 125, which breaks down to 25 times 5, and 25 is 5 times 5. And I have a pair of 5s with a 5 left over. Pair of 5s with a 5 left over, that's 5 radical 5. So this is 5 radical 5. So I have 5 radical 5, I have 10, and I have 5. So I have to add 5 plus 10 plus 5 radical 5. But remember, we can only add if we have like terms. So we can add the 5 and the 10, and that's it. So we're going to have 15 plus 5 radical 5. And it looks like we can add the 5 and the 15, but we can't. Because again, it's not 5, it's 5 radical 5. You got to make sure you have like terms in order to add. So I would leave it in radical form, 15 plus 5 radical 5. If they tell us exact perimeter, you would do that. If it said to the nearest something, nearest tenth or nearest hundredth, you put that in your calculator, get a decimal, and round it off. Now area is a little different. if you could count the area, that's nice. In these two examples here, we can count the base or height the way they're graphed. This one here, we could count, right, from this point to this point right here. 1, 2, 3, 4, 5. So 5, they're calling it centimeters. It doesn't, if each block is a centimeter or whatever. But it's 5 units across. And then you need the height. The height is from the base straight up, so it'll be right here. Okay? So it's right here. Count up. 1, 2, 3. So the base is 5 and the height is 3, and you can count it that way. Make sure it is a base and a height. So how do I find the area of the triangle? Well, area is 1/2 base times height. We should know that for a triangle. So that's going to be 1/2 of 5 times 3, and half of 15 is 7.5. So the area of that triangle would be 7.5. Another example here, we could count. It's 1, 2, 3, 4 up and down, so that I could see the height is 4, and then this base here, we have to go across. It's got to be this and this, or it doesn't work. Across, it's 1, 2, 3, 4, 5. So this would be 1/2 of 4 times 5. Half of 20 is 10. So we'd have an area of 10. This triangle would be an area of 10. Now, if we can't count, and if we have more complex things like pentagon, octagon, and all that, if we can't count, we're going to use what's called the box technique. This is pretty much the end of the video here, this box technique. We're going to do 2 of these. We're going to do a triangle, and then we're going to do a quadrilateral. All right, it's 4 sides. It doesn't have to be a rectangle. It doesn't have to be a rhombus or a square or a parallelogram. It can just be a quadrilateral, 4 sides. And then we'll use that to apply it to more other polygons, like with more sides, hexagons, pentagons, octagons, and all that. So to use the box technique, what we're going to do is draw a box, or box in, basically, box in the triangle. So I'm going to do it here. It's done over here for me, but I'm going to do it here as if, say pretend I couldn't, I didn't have this extra graph. I'm going to box it in. Okay, so I'm doing that right here. And again, it's already done for us on the right over there. So what that does, and what you're trying to do, is you're actually trying to find the area of this right here. Okay, you're trying to find the area of this triangle. So what I can do is find the area of the rectangle that I just made, the box I just made, because I know that's easy, because for a rectangle, area is base times height or length times width. Call it length times width. So I know it's just whatever it is up and down times whatever it is left and right. And then I'm going to subtract the areas that are white. Now what I did here is we colored them, and on your paper it's shaded, but we colored the areas we're going to need to find. But essentially you're finding the areas that are white, and we're going to subtract that away. So when we do length times width, okay, the rectangle, it's 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, just 4, right? 1, 2, 3, 4. So it's 7 by 4. 7 by 4. 7 times 4 is 28. So I know that all this area, the area of this, all this right here, all this, all that, and the triangle, all that is 28. I want to take away, I want to subtract, that, I want to subtract that, and I want to subtract that. And I'm going to get rid of this because I think it's confusing. All right. So I want to do that now. after I fix my box. So now I have 3 triangles I got to find the area of. So it's going to be minus. Now how do I find the area of a triangle? I'm going to go over here. This is a 2 by 1, 2, 3, 4, 5, 6, 7. That's a 2 by 7. But it's a triangle, so I got to do half. 1/2 of 2 times 7, or divide by 2. Then I have the green one, 2 by 1, 2, 3, 4, 5. That's a 2 by 5. But again, I got to do half. 1/2 base times height. And then this one's 1, 2, 3, 4 by 2. So 2 by 4. And then I got to do half. So basically, figure out what all these are and just subtract. This is 14 over 2, which is 7. This is 10 over 2, which is 5. This is 8 over 2, which is 4. So I need to 28 minus 7 minus 5 minus 4, and that comes out to be 12. So my area of my triangle is 12 by doing the rectangle minus all the triangles. Could do the same thing here. Now it's a quadrilateral, but it works for all polygons. I'm just going to box it in. Box it in. Okay. 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7. It's a 5 by 7. Okay, so it's 35 total minus all these. So now what I did here is I made 1, 2, 3, 4, 5 things that I got to take away, because see this kind of weird shaped, if you look here, it's kind of weird shaped. Like, what's this white area here? Well, it's a triangle here, and then a triangle here, and then a little rectangle, a little square here. So if I just find all these areas, orange, green, yellow, purple, blue, subtract all those, I'll be left with this area, which is what I want. All right, so orange is 1, 2, 3, 4 by 1. So that's 4 by 1 divided by 2. And then the yellow is 1 by 1, 2, 3, 4. So that's also 4 by 1. And then minus blue, 1, 2, 3, 4, 5, 6, 7 by 1. That's a 7 by 1 triangle divided by 2. And then this purple one is 1, 2, 3, 4 by 2. That's a 4 by 2 divided by 2. And then don't forget the green. That's a 1 by 1. 1 times 1 is 1. So we're just going to take away 1. So this is, I'm going to do the work down here, 35 minus 4 over 2, 2. 4 over 2 minus 2. 7 over 2 minus 3.5. 8 over 2 minus 4, and then minus 1. So I had to do 35 minus 2 minus 2 minus 3.5 minus 4 minus 1, and that comes out to be 22.5 would be the area of my quadrilateral in this case. And again, it wouldn't matter. It wouldn't matter if it was a hexagon, pentagon, octagon, whatever, however many sides, it doesn't matter, because we're just going to box it in, do the boxed area, and subtract away all the triangles or all the pieces that aren't, subtract away the pieces that aren't the polygon, the outside pieces. Okay?